So, dear colleagues, today I would like to show you results of long-term research. And it's a research which shows in how far archaeological prospection can change our view of the past. And if you follow me, we are also going to detect the landscape which is long forgotten. And I will bring you to the Kvarner Bay, the northern Adriatic, so we go southwards from Czech Republic, and we are here in this area between the peninsula of Istria and the Croatian mainland, mainly with the islands of Cres, Krk, Lošinj and Rab, and I will be talking about Cres and Krk in this presentation. The research started in 2012 when we had the opportunity to use a green laser which can penetrate clear water, and of course this kind of area is perfect as a showcase for this. Why? Because we have here in this area limestone, which very clear water, where the penetration can be up to 10 meters deep. We have rising water levels since Roman times by 1.5 meters, which means we have many submerged sites, and we have an interesting landscape which is full of macchia, which is a difficult terrain, which is also very good to see if this kind of urban laser scanning works also in this area. So this was 13 years ago, and you can see here the result of this scan, and what you see here in red is an interpretation which I started a few years later, where you see that in this area, this is full of archaeology. It's a karstic area, it's dominated by dry stone walls and by terraces, and most of them are not recent because agriculture stopped here somewhere around the Second World War. Because it's a big area, we decided to take a small sample area and make a publication from it. We brought Dave Cowley in and we worked on this together. And this is here in Punta Grigia, which is the southern part of the island of Cres. And you can see here the macchia, and that's the laser scan or the digital feature model from the laser scan. And what I did here was a thorough interpretation, but, and I think that's important, because most people use urban laser scanning like an aerial photograph. They make a visualization and they interpret what they see like crop marks or soil marks. But you can do more, because usually in an urban laser scan you would see if two things are intersecting, which is older and which is younger. So you can make a stratigraphic interpretation, which we did, and this is a Harris matrix which I made from all these features, and we can see at least 5 phases in this area. Also interesting from field survey, it would be a so-called non-site area, which I think is a nonsense term in terms of landscape archaeology. But still we got 5 phases, and very shortly, because I presented this at AARG in Zagreb in 23. But just as a reminder, the youngest phase here is these red lines. This is single dry stone walls, which are easily built up and which are probably in connection in the 20th century with olive orchards and sheep farming. So agro-pastoral landscape. Before we have a big process or events of clearing of the soil. So the green are clearance piles of stones piled against walls from phase 3. These walls, and this is only part of phase 3, we are here in the time around the turn of the 18th century. In 1821, the Franciscan cadastral map was made, and you can see some of these walls mapped in the cadastral map, and you can see it was like a vine-growing area at the time. And also, what you see is in these areas we have already macchia, secondary vegetation, which shows that what we see below that, these terraces must be quite older than that. So this would be phase 4, and finally in phase 5 we saw a bank which is completely straight and extending over 1 kilometer when the laser scan ends, so it goes further. And you know, lines, straight lines being unmotivated in the landscape, it smells like Roman. So I said this could be Roman, and the answer was no, can't be. Why? Because we don't have Roman land division on the islands, because this is just municipia. Roman land division is bound to Colonie, which is on the mainland, so it can't be. So Michael, think of something else. So I looked in the surrounding, and what I saw is, I saw also parallel lines with the same direction, and the distances are between 683, 714 meters, which comes very close to this Roman Actus with 710 meters. And it became more and more convincing. So what we did finally, we walked there, of course. They're in different shapes. Sometimes you just see the bank. Sometimes you see something like a disintegrated dry stone wall. And in some areas, you still see dry stone walls, probably knee high, so 30 to 50 centimeter high. And we published this in 2022. It's an open access publication. It's a long publication because we have a big methodological part where we explain how we interpreted, why we did what we did, how we did the stratigraphic approach, and so on. But at the time, we already wrote in this publication, we think it could be a Roman land division, but we were not sure, and this meant we needed further research. And this happened from 2023 onwards, when Nives became PI of a project which was funded by the Austrian Science Fund, and the project was called Osser Beyond the Myth. It's a landscape archaeology project based on Osser, which is the small town on the land bridge between the islands of Cres and Lochin. And what we have seen before was more or less the hinterland of Osser. It's a multidisciplinary approach with, of course, laser scanning is involved, but also we have a cooperation with the Croatian Geological Institute. They are very professional, and they have multi-beam sonar, but they are making also drilling underwater, because we would be interested, because this area is silting up, and we are interested of when this silting up started, which might also mean when was the land cleared and used for agriculture first time. This is all work in progress. Here you can see what is nicely fitting is here the multi-beam sonar, and this is the terrain model from the airborne laser scan. It fitted very nicely together, and now we have a coherent terrain model from minus 50 meter up to the highest peak here in the terrestrial landscape. We did intensive geophysics, so every spot which was available in Osser and surroundings was measured with georadar and magnetics. And most importantly for this presentation, we did some OSL dating, optically stimulated luminescence profiling and dating of some of these walls. You have here two parallel presumed Roman dry stone walls, and we brought a team here from the University of St. Andrews and Newcastle to help us with this, because they're really professional, because they are for several years already dating terraces and other features in the Mediterranean. Now the process is, first it is evaluated if the sediment there is susceptible for OSL dating. Then there's profiles made, and they are screened to find the profile, the samples which are best to date what we want to date. So we went there in February 2024. As I said, Tim Kearnott from the University of St. Andrews, Sam Terma, and Christopher Sevara. Some of you know Christopher Sevara. Together, and from the Austrian side, it was Nives, myself, Martin Ferrer, and Doris Jetzinger, who helped there. She was documenting what we excavated here. So we made small trenches through these walls. And on site, it was checked, and we saw that there is a good capability of getting proper OSL data because of the sediment. It was then, here you can see the locations of the steel cylinders which were driven into the ground to get the samples in a kind of profile. Where we couldn't drive in the steel cylinder, the whole thing was covered, and the material was scratched out in complete darkness. And then it was screened in the laboratory, and you can get here some relative ages. So this is not absolute ages, of course, here, but you could see in this profile where suddenly something happens. And this is exactly the point where we want to be, because the wall was constructed because there was a small channel dug and then the dry stone wall built. And in this disturbance, you can see it here in the screening, and that's where you have to measure your OSL dates finally. And the measurement turned out to be here, with both parallel walls in a weight combination, we are here around 80, 200 plus minus 100 years. So in any way, we are in Roman time. So we could confirm with this that these walls, at least these walls where we sampled, are in fact of a Roman age. Meanwhile, fortunately, and we have seen this already before in the presentation, and if you look at Sarah's poster, they're also making use of this nationwide laser scan in Croatia. It's a real game changer for Croatian archaeology, I think. And I must say, it's perfect data set. It's really nicely done, especially the the classification of the data is done in a very good way, so you can have really nice terrain model to look at. And I think Shiga can also confirm this because he's also working with this data. It's nationwide. It's free to use, but it's not in a way that you simply download it, you have to ask for it. But you will receive it and you will receive it for free. Usually, you should. It's 1 meter resolution, but it's very good, and it didn't take us very long to find more of these walls. Why? Because we knew where to look at and we knew how these things should look like. So you see here in the upper images, this is a wall on the island of Cres, but we found also walls on the island of Krk, and you see the orientation is different. While on Cres, the orientation is the same as we have seen before in our own data set. On the island of Krk, there's something else happening. Now, we did a thorough interpretation of both islands, also of Lošinj and on Rab, but there we didn't find anything so far. But on Cres, you see here in the red lines, this was our research area before, and you can see that we see these lines over a distance of 35 kilometers. And as we had suspected before, because our laser scan stopped here, they're crossing usually the entire island. We don't see, of course, all of these walls, but the distances are in principle. So the orientation is 65 degrees if you take UTM 33. The distances are between 630 and 720 meters, so it's not an exact 710 meter system. You will see them mainly in the flat areas. Here in the north, the terrain becomes extremely steep and absolutely not for agriculture, so that's probably also the reason why they stop here in the area of Cres. And also interesting, if you look here at these two lines, if you take the exact center line and prolong it, it's exactly going on the main road into Osor, north of the forum where the excavation showed the potential remains of a temple, which could be the zero line for this grid. So the alignment is also with the Roman site of Osor. Going to Krk, we see even more. We have here two systems. One is here in the central area. It's covering a length of 70 kilometers. It has an orientation of 53 degrees. The average distance is approximately 706 meters. It has a lot of cross connections, so it's really this kind of checkboard pattern we would like to see in a limitatio. And it's aligned with the orientation of the Roman town of Krk, or Curicum, as it was called at the time. And in the north, we have a different system, which is east-west oriented, with a mean distance of really 710 meters. And it's aligned and oriented to Fulfinum, the Roman Fulfinum, today Omišalj. None of these walls had been known previously as Roman, so this is a completely new landscape which we detected using this open data. And of course, I hope you believe me that we are really confirmed that this is now really a Roman land surveying which we have on these islands. The distances and lengths are not uniform, but in this area on Cres and Krk North, it's probably a scamnatio, a kind of horizontal strip surveying, while in the central area of Krk we have a centuriatio with these typical checkboard patterns. But we need, of course, further investigation because we want to have a more detailed interpretation of this. We would like to investigate also the relationship to the Iron Age hill forts, because we see that these walls stop. And also, I think you presented this also already on Istria. They tend to stop in front of a hill fort and go on after the hill fort, so they don't go over the hill fort, which are presumably Iron Age. Also interesting, how were these walls treated after the Roman era? Why are some walls completely disintegrated and other walls are still standing? Of course, it has to do with what happened after the Roman time. And also to investigate if these walls are on other islands too. There should be. Now, to the conclusion, we think that evolution of new methods in archaeology also demand an evolution of our research questions. We should treat data really in a way they're capable to do. So airborne laser scanning, as I said, is not aerial archaeology. Visualizations are important and we use them, but we should not treat them as an aerial photograph. We should do more with it because airborne laser scanning can do much more than an aerial photograph. And we have to shift, of course, our focus from the sites to the landscape. Because, as I said before, this is all non-site area, and this is really not a very helpful term in terms of landscape archaeology, because you see there is a lot of going on there. Stratigraphic analysis, I think, is really a key to interpreting airborne laser scanning datasets. And we know this stratigraphic analysis already for a long time from field walking and from field survey in Britain, for example. Dry stone walls can be dated using OSL technology, and this is the good news, because we really can give this stratigraphic analysis absolute dates, and I think that's very important. And of course, we got in this way new insights in the current state of the art. And also, I think I would like to stress that this is not a lucky coincidence. It is a research, a long-lasting strategic research, which was going further and further in its research questions. So there is the serendipity is maybe there where we started, but not during the research. And with this, this is published in English and in Croatian, in a Croatian journal. It's open access, and who is interested can have further knowledge of it. And with this, I'm happy to answer your questions. Thank you.